Hello everyone, my name is Pratik Savule and today I am going to present topic accuracy, precision, recall, F1 score for the deep learning INC1. So let us begin. So whenever we train our ML model, we need a way to judge our model, how good or bad it is. The simplest way is accuracy, which tells the fraction of correct prediction to the total number of prediction. But accuracy alone is not reliable. Suppose we have a case of imbalanced dataset where 95% samples are negative and 5% samples are positive. A model predicting all samples as a negative gets 95% accuracy, which seems to be good. But accuracy ignores the type of error caused by false positives or false negatives. So we need detailed matrices such like precision, recall, and F1 score for deeper insight into our model. This matrix helps to decide whether our model is safe, reliable, or useful for that particular task. Let us take example of a medical diagnosis in cancer detection. If our model has 95% accuracy, it may still miss most of cancer patients if the data set is truly imbalanced. So what is accuracy? Accuracy is simply defined by ratio of correctly predicted samples to the total number of samples. The formula is given here. We will discuss it later after understanding confusion matrix. But the concept of accuracy came from classical statistics, means a proportion of a correct outcomes to the total number of trials. So as we discussed, it is misleading in case of class imbalance. Precision. Precision is simply defined by out of positive predicted positives, how many are actually positives. If the precision is high, then our model makes few false alarms. But this also can be misleading in the case of class imbalance. Let's take example of a spam detection. Suppose our model predicted 50 emails as a spam, but only 45 were truly spam. Then the precision can be 90%. We can say that our model has few false alarms because the precision was pretty high, that was 90%. Recall. Recalls asks that out of actual positives, how many were detected? It is also derived from classical statistics. If the recall is high, then model catches all the important cases. Let's take example of a cancer detection again. If our model detected 20, our data set has 20 positive samples of a cancer patients, and if it detected 15, then the recall can be 75%. Now F1 score combines precision and recall with its harmonic mean. It is useful when we have imbalanced data set. If suppose precision is high or recall is low, or recall is high and precision is low, then it penalizes the imbalance between precision and recall. It is useful when our data set is imbalanced. So now let us understand how we calculate precision, recall, and how we understand that our model is making good predictions or not. First, before that, we need to understand what is confusion matrix. The confusion matrix is a 2 by 2 cross 2 table comparing predictions versus actual outcomes. There are four components. First is true positive. True positive means model predicted positive and the result was actually positive. False positives. Model predicted positive but result was negative. True negative. Model predicted negative and the result was negative. And false negative. Model predicted negative and the result was positive. The confusion matrix looks like this. So let us understand it with example. Before going to example, let us understand steps to compute matrix and interpret it. So first we collect all the predictions from the model on the test data set. Then we build confusion matrix and count true positive, false positives, true negatives and false negatives. Then we apply formulas such as accuracy is equals to true positive plus true negative upon total samples. Precision is true positive upon true positive plus false positive. And recall is true positive upon true positive plus false negative. And F1 score is simply 2 into precision into recall upon precision plus recall. Uh, how to interpret our result of our model? If the precision is high, then our model makes reliable predictions and few false alarms. If the recall is high, then most of positive results are caught. And if the F1 score is high, then there is balanced trade-off between precision and recall. Let's take an example of a spam detection model. Suppose we test 100 emails. Out of that, 45 are true positive, 20 are false negative, 5 are false positive, and 30 are true negative. So as per calculation of calculations by given formulas, accuracy is 75%, precision is 90%, recall is 69.23%, and F1 score is 81.32%. Now, interpretations. Accuracy is 75%. Model is correct in 3 out of 4 cases overall. Precision is 90%. Means it is has few false alarms. Recall is 69.23%. Model misses 30% of actual positive cases. And F1 score is 81.3%. There is good trade-off between precision and recall. But recall is still weaker. Now let us discuss limitations of this matrix. As we discussed, accuracy is performed poorly on imbalanced dataset, and there is concept called precision versus recall trade-off. Let's understand it with example. If there is stricter spam filtering, then precision is generally higher and recall is lower. If there is latent spam filtering, then generally recall is higher and precision is lower. Now, F1 score treats precision and recall equally important, but in some cases, one may be more important. Like in some cases, precision is more important, and in some cases, recall is more important. Like in medicines, recall can be more critical. Also, matrix doesn't check the confidence of the model. Like in this example, model B is more confident than model A, but the matrix for these both models are same. Now to summarize, accuracy is overall correctness of the prediction and it can be misleading in imbalanced dataset. Precision means reliability of positive predictions it reduces false alarms. And recall is ability to detect actual predictions and it reduces missed cases. And F1 score means balance between precision and recall and it is useful in imbalanced dataset case.